Some of the most rare-looking minerals in the world aren't rare at all. They're common, everywhere, hiding in plain sight, misjudged for decades simply because no one ever learned how to look at them properly. Collectors with the sharpest eyesight, the longest experience, and the deepest respect for geological precision quietly agree on one thing. True connoisseurship isn't proven by exotic gems, but by recognizing value in stones everyone else overlooks. These minerals sit in riverbeds, mine dumps, gift shops, and canyon floors. Stones most people would step over without hesitation. Yet under the right conditions, they reveal refinement, structure, and optical behavior that only a trained eye can appreciate. And at the very top of this list lies a mineral so misunderstood, so dramatically undervalued, that elite collectors consider its finest specimens a kind of secret currency. This is the world of common minerals, where the real test of expertise begins. Let's start the countdown. Ranked 10th, quartz, the beginner mineral that tests experts. Quartz is often introduced as the simplest mineral in the world of geology, the stone anyone can identify, the material found in beaches, countertops, hiking trails, and children's science kits. Because of this familiarity, many assume it holds no secrets. Yet among experts with decades of fieldwork and laboratory analysis behind them, quartz is regarded not as an entry-level mineral, but as a silent exam. It reveals how deeply a collector understands structure, clarity, and the behavior of light itself. At first glance, quartz appears predictable. Its transparency seems obvious, its structure straightforward. But this simplicity is deceptive. Quartz, in truth, is one of the most demanding minerals to evaluate correctly. Its value lies not in color or rarity, but in the precision of its internal world, a world that only reveals itself through disciplined observation. The first layer of expertise lies in understanding clarity hierarchy. Common quartz contains veils, fractures, and cloudiness that scatter light in uneven directions. High-grade quartz, however, displays a clarity so pure it feels weightless, as though the mineral holds nothing inside except the memory of its own growth. Identifying this purity is a skill that develops only through years of studying how fluid inclusions, stress lines, and phantom zones interact with external illumination. Next is growth geometry, the element that distinguishes experienced mineralogists from casual observers. A quartz crystal is a slow archive of geological history. Clean terminations indicate uninterrupted growth. Fine phantom lines mark subtle changes in temperature and pressure. Twinning patterns, often invisible at first, reveal dynamic shifts in the environment the crystal formed in. Each detail is a signature, and reading these signatures correctly requires a refined eye. But the true test comes from light discipline. Unlike gemstones designed to sparkle aggressively, elite quartz does not rely on brilliance. Instead, it bends and concentrates light with remarkable restraint. When illumination passes through perfect quartz, it doesn't scatter. It moves with intention. Experts watch how a beam slows inside the crystal, how edges channel brightness, how internal planes behave like quiet mirrors. This controlled interaction with light is one of the strongest indicators of elite quality. Quartz's value, therefore, is not rooted in rarity, but in precision. It rewards those who appreciate structure, consistency, and the physics of minerals. To seasoned collectors, a flawless quartz crystal communicates something profound, an understanding of fundamentals. Many minerals impress at first sight. Quartz impresses upon deeper inspection. It is a stone that does not chase admiration, it demands comprehension. In the world of connoisseurship, this makes quartz uniquely revealing. Anyone can desire color, anyone can desire rarity, but only those who understand quartz truly understand mineral quality itself. Ranked 9th, calcite, the optical stone. Everyone underestimates. Calcite has long been dismissed as a soft mineral, a material too common, too fragile, and too easily scratched to command serious respect. Yet in professional mineral circles, calcite holds a status that outsiders rarely understand. Beneath its modest reputation lies one of the most complex optical behaviors in the mineral kingdom. A behavior so refined that scientists still use calcite as a reference point for understanding the physics of light. Most stones reveal their beauty through color or durability. Calcite reveals its beauty through behavior. It interacts with light in ways that few common minerals can replicate. And this subtle mastery is exactly why seasoned collectors and optical mineralogists study it with the same attention typically reserved for far rarer stones. The most defining feature is double refraction, a phenomenon so distinctive that a single clean calcite rome can split an image into two. To beginners, this effect looks like a curiosity. To experts, it is a diagnostic signature. It shows how perfectly aligned the crystal lattice is, how few internal disruptions exist, and how true the angles of formation remain. High-grade calcite behaves almost like engineered glass, crisp, bright, and unbending in its command of light. Low-grade calcite, by contrast, reveals cloudy patches, distorted inclusions, or structural irregularities that break the delicate optical pathway. Spotting this difference instantly separates experienced eyes from casual observers. Then there is color discipline, a characteristic often misunderstood. Pure calcite is not meant to display strong color. Its value lies in transparency, clarity, and the evenness of its internal medium. When color appears, it must appear with purpose. Soft honey yellows, clean amber tones, or rare ice blues created by trace elements or geological environments unique enough to justify the shift. Experts evaluate whether the color enhances or disrupts the optical purity calcite is known for. Another overlooked trait is cleavage perfection. Calcite breaks along precise planes, creating rhombohedral forms that look mathematically constructed. Smooth surfaces, sharp angles, and a lack of chipping are markers of quality. When a specimen displays ideal cleavage without fracture webs, it signals exceptional environmental stability during formation, a subtle clue that specialists notice instantly. And perhaps the greatest test of connoisseurship lies in identifying calcite that remains visually calm even under intense light. High-value pieces have a serenity to them. No haze, no diffusion, no internal turbulence. Just a quiet, confident transparency that behaves like frozen illumination. For these reasons, calcite is more than a mineral. It is an examination of observation skills. The stone rewards those who appreciate precision over durability, geometry over glamour, and optical truth over surface appeal. In mineral collecting, calcite teaches a lesson few expect. The simplest stones are often the most demanding to understand. Ranked 8th, Feldspar. The stone that only shimmers for the patient eye. In landscapes shaped by erosion and time, feldspar blends into the background so completely that its quiet shimmer often goes unnoticed. Yet seasoned collectors and gem experts understand a truth that newcomers rarely notice. Among common minerals, feldspar contains some of the most sophisticated optical effects in the natural world. These effects do not reveal themselves quickly. They unfold slowly, requiring patience, controlled lighting, and an eye trained to observe subtle shifts rather than loud displays. The most famous expression of feldspar's elegance is schiller, the soft, internal shimmer often seen in moonstone, sunstone, and labradorite. But outside the realm of jewelry, high-grade feldspar specimens exhibit this phenomenon in ways far more delicate. The shimmer is not the sparkle of quartz or the defined banding of agate. Instead, it's a gentle, almost meditative flash that appears only when the mineral is angled with intention. Experienced mineralogists watch for a phenomenon described as quiet motion, where internal lamellae catch the light like distant reflections on water. This effect is controlled by the microstructure of feldspar. Layers of alternating composition form through slow cooling inside the earth. These microscopic separations act as natural diffraction gratings, producing soft light play. The closer these lamellae are to perfect alignment, the more refined the shimmer becomes. High-quality feldspar doesn't shout for attention. It rewards a viewer who pauses and studies the stone as light moves across its surface. Another connoisseur indicator lies in texture and transparency. Most feldspar is opaque or cloudy, but exceptional pieces exhibit a semi-translucent glow that gives the mineral a ceramic-like quality. This subtle diffusion of light creates an impression of depth, as though illumination sinks into the stone before returning to the surface. Collectors often compare this property to fine porcelain, simple at first glance, elegant upon sustained observation. Color also plays a quiet but important role. Pure feldspar tends towards soft whites, gentle creams, or muted grays. When color does appear, such as the warm copper flashes of Oregon sunstone or the cold fire of labradorite, experts evaluate not the intensity but the discipline of the effect. Controlled, even color transitions indicate a stable growth environment and high structural integrity. Finally, feldspar tests a collector's willingness to appreciate understatement. Many minerals reveal their value instantly. Feldspar reveals it reluctantly, and that restraint is part of its charm. To recognize elite feldspar is to understand how subtle beauty works, how light, structure, and motion can create complexity without spectacle. Among connoisseurs, feldspar holds a quiet prestige. It is the mineral that asks the observer to slow down, adjust the light, and look again, because true shimmer belongs to those who wait for it. Ranked 7th, Sodalite, the cheap stone that looks luxurious when perfect. Almost every collector remembers the moment sodalite shifted in their mind from inexpensive blue rock to a mineral capable of real architectural beauty. What sets elite sodalite apart is discipline of color. Ordinary material shows faded navy, patchy tones, or poorly balanced veining. High-grade sodalite, however, displays a deep ultramarine so saturated and even that it resembles natural velvet. This richness is not merely attractive. It signals stable growth conditions, low impurity levels, and an alignment of the mineral's internal structure that specialists immediately recognize. When placed under soft light, premium sodalite behaves almost like a luxury fabric, absorbing brightness while releasing a subtle, controlled glow. Another key indicator is matrix precision. Sodalite's iconic white veining is not meant to be random. In exceptional specimens, these lines form clean, organized patterns that contrast beautifully against the blue body. This balance between light and dark is what gives high-end sodalite its unmistakable sophistication. Designers often describe it as geological minimalism, where nature's patterns mimic intentional, modern aesthetics. When the veining becomes chaotic or muddy, the mineral loses its elegance. When the pattern is crisp and architectural, sodalite begins to look far more expensive than it is. Transparency also contributes to connoisseur value. Although sodalite is typically opaque, rare pieces exhibit partial translucency along their edges. This subtle glow suggests purity and tight structural cohesion. Under directional lighting, these zones create depth, an optical effect prized by experts who evaluate minerals not only by color, but by the sensation of dimensionality they evoke. One of the most overlooked elements is surface finish behavior. When polished correctly, elite sodalite develops a sheen that feels refined, almost ceramic. This glow is softer than the shine of quartz and more controlled than the luster of obsidian. Connoisseurs seek pieces that maintain this polish evenly, without grainy interruptions or dull patches. Clean polish indicates that the mineral's internal grains are fine, aligned, and compact, traits found only in superior specimens. Above all, sodalite tests perception. Many minerals demonstrate their value immediately. Sodalite asks viewers to reconsider their assumptions. It transforms from cheap to luxurious, not through rarity, but through the refinement of its quality. When the color is deep, the veining disciplined, and the finish elegant, sodalite embodies a quiet sophistication found in the finest natural materials. Collectors who appreciate high-grade sodalite often value subtlety over spectacle. They recognize that true luxury is not loud. It's precise, balanced, and unmistakably intentional. Ranked 6th, Chalcedony, the ultra-common material with high-end variance. Before color or pattern even enters the conversation, Chalcedony announces its quality through texture, a softness of light that reveals its micro-crystalline nature. The most defining characteristic of chalcedony is its texture on the microscopic level. Unlike quartz, which forms large visible crystals, chalcedony is composed of extremely fine inner growths of silica fibers. These fibers determine everything: translucency, glow, color discipline, and the mineral's signature soft focus appearance. Ordinary chalcedony looks dull or waxy, Exceptional chalcedony appears alive, as though lit from within by a calm internal lantern. Experts evaluate chalcedony first through light diffusion. High-grade specimens do not simply allow light to pass. They disperse it evenly, creating a smooth radiance that feels almost liquid. This effect is subtle but unmistakable. In certain pieces, the glow is so uniform that the mineral seems to contain its own atmosphere, producing a visual calmness that collectors find deeply satisfying. Low-grade chalcedony shows patchiness or uneven opacity. Elite material displays consistency and balance. Another critical indicator is color purity. Chalcedony can appear in nearly every soft tone nature offers: pale blues, gentle lavenders, warm grays, and milky whites. But connoisseurs are not drawn to boldness. They seek coherence. A fine chalcedony specimen maintains a single disciplined color field from edge to center, without abrupt clouds or muddy transitions. This uniformity signals stability during formation, often requiring millions of years of slow geological refinement. The next layer of evaluation is surface quality. Chalcedony should feel smooth, almost porcelain-like, when polished. This silky finish results from the tight interlocking of microscopic fibers, a structural precision that cheaper grades simply cannot replicate. When the surface reflects light softly rather than sharply, specialists know they are dealing with material of exceptional density and cohesion. Collectors also pay close attention to form and thickness. Chalcedony that holds consistent translucency, even in thicker sections, is considered highly desirable. It suggests purity and uniform grain throughout the entire mass. Slabs, nodules, and carved pieces that maintain this glow demonstrate an elevated level of natural refinement rarely found in lower quality deposits. What makes chalcedony particularly fascinating is how dramatically its value shifts between ordinary and elite forms. To an untrained observer, both may look similar, but experts immediately recognize the difference in depth, light behavior, and structural harmony. This ability to distinguish the subtle from the common is what turns chalcedony into a connoisseur's mineral. Among refined collectors, chalcedony represents a quiet type of sophistication. It is a reminder that beauty does not always come from striking colors or dramatic patterns. Sometimes it emerges from harmony, discipline, and the gentle glow of perfect microstructure. Ranked fifth, fluorite, the child's stone, until the colors align perfectly. What begins as a child's curiosity stone becomes, with the right structure and color alignment, one of the most disciplined minerals in the collector world. The first marker experts evaluate is zoning clarity. Fluorite forms in layers, each recording a shift in temperature, pressure, or chemical composition. In ordinary specimens, these zones appear blurred or inconsistent. But in high-end fluorite, the transitions between colors are sharply defined, perfectly straight, razor clean, and aligned with the cube-like symmetry of the mineral structure. This visual order signals purity of environment and stability during growth. Specialists value these clean boundaries the way art collectors value precise brushwork. Next is color alignment. Fluorite's palette is famously diverse, but connoisseurs look not for the brightest colors, but for harmony. Premium pieces display colors that complement one another naturally. Deep royal purples paired with icy greens, soft blues transitioning into luminous aquas, or honey tones arranged in balanced geometric blocks. When light passes through these aligned layers, the mineral produces a visual effect that feels architectural, a geological stained glass window shaped by millions of years. The evaluation continues with internal clarity and luminosity. High-grade fluorite is not merely transparent, it glows. Light moves through it softly, illuminating the colors without creating turbulence or haze. This glow is especially prized in thick crystals, where transparency becomes a test of chemical purity. When fluorite maintains clarity even through substantial depth, it indicates an unusually clean growth environment, a rarity that collectors immediately recognize. Another critical trait is structural perfection. True cubic faces, sharp edges, and undamaged corners elevate the value dramatically. Fluorite's softness makes pristine specimens extremely difficult to preserve, which is why flawless geometry commands significant respect among experts. The mineral's sensitive nature becomes part of its elegance. A reminder that beauty often coexists with fragility. Finally, fluorite's most surprising quality emerges under UV illumination. Many high-grade pieces fluoresce in vivid blues or violet glows, revealing a hidden dimension of their identity. This luminous response adds depth to their character, turning an already intricate mineral into something almost ethereal. For all these reasons, fluorite stands as a mineral that grows with the collector. It may begin as a childhood fascination, but as an appreciation for structure, color, and optical precision deepens. Fluorite becomes a symbol of elevated taste. In connoisseurship circles, perfectly zoned fluorite represents a simple truth. Even the most playful stones can become masterpieces when nature organizes their colors with ranked fourth, hematite, the gift shop mineral that becomes elite in mirror grade. The leap from gift shop stone to elite metallic collectible happens quickly with hematite, the moment its surface crosses in a true mirror grade. In professional mineral circles, hematite holds one of the most dramatic quality gaps among common minerals. Ordinary pieces may fill bins in shops, but true mirror-grade hematite belongs to a completely separate category, a rarity defined by structural precision, metallic purity, and the kind of reflective brilliance usually associated with fine sculpture or industrial metalwork. The transformation begins with luster discipline. Most gift shop hematite has a dull, uneven shine resulting from surface treatments, tumbling, or internal grain inconsistencies. Mirror-grade hematite, however, exhibits a metallic reflectivity so sharp it behaves like a natural mirror. The reflection is not symbolic, it is literal. Faces, objects, and surrounding light appear on its surface with clarity akin to polished steel. This effect is created only when the mineral forms under stable iron-rich conditions and cools slowly enough for its microscopic grains to align tightly. Color also reveals the stone's quality. Inferior material appears muddy gray or patchy. Elite hematite shows an unbroken jet black metallic tone, deep and uniform, absorbing light while reflecting it. This paradox, darkness with brilliance, is what connoisseurs prize. Under controlled lighting, the surface produces subtle highlights that look almost architectural, as if the mineral were a piece of forged metal shaped by human hands rather than geology. Another marker experts seek is surface integrity. Hematite is naturally brittle. Achieving a smooth, uninterrupted surface requires both exceptional raw material and meticulous cutting. Any microchip or grain boundary breaks the illusion of perfect metal, so mirror-grade pieces displaying flawless surfaces are extraordinarily rare. When found in natural geometric forms, especially botryoidal growths with clean, domed curvature, their sculptural elegance elevates them far beyond common mineral status. Internal density is equally significant. Hematite is among the heaviest common minerals, but elite specimens have a solidity that feels almost engineered. This weight signals high iron purity and minimal internal porosity, qualities prized by collectors who evaluate minerals not only by aesthetics, but by physical presence. In addition, hematite tells a geological story that few casual observers recognize. Mirror-grade formations often originate in environments where iron precipitation occurred with remarkable consistency, creating uninterrupted layers of metallic crystal growth. This stability translates into the clean, polished appearance experts value. The contrast between mass-market hematite and elite hematite reveals a broader truth about connoisseurship. Value is not always about rarity, but refinement. The mineral's elevation from gift shop stone to collector's metal depends entirely on purity, structure, and the precision of its reflective surface. For those who understand these details, mirror-grade hematite becomes a symbol of disciplined beauty, a stone that looks simple until the light reveals everything. Ranked third, Rhyolite, the field rock that turns into natural art. Some rocks hold landscapes within them, and rhyolite is perhaps the clearest example of nature creating art without ever intending to. What sets rhyolite apart is its internal composition. Formed from high silica lava that cools rapidly at the surface, rhyolite traps within it swirls of microcrystals, suspended fragments, and layered flows that behave like broad brushstrokes. When cut or polished, these structures reveal patterns that resemble landscapes, abstract paintings, or weathered parchment. The stone becomes more than a geological specimen. It becomes a canvas recording moments of volcanic motion. Experts evaluate rhyolite first through its pattern clarity. Ordinary rhyolite displays chaotic or indistinct markings. High-end material shows deliberate-looking flow lines, concentric circles, or landscape-like scenes. In exceptional pieces, the mineral seems to contain miniature deserts, mountains, or stormy skies. Complete compositions arranged entirely by chance, yet remarkably artistic. This phenomenon is what collectors refer to as geological imagery, and it is the primary reason rhyolite holds prestige in the world of natural art stones. Color harmony is another hallmark of elite rhyolite. The mineral can form in a range of earth tones: olive greens, muted reds, warm browns, soft yellows, and dusty grays. But quality specimens balance these colors with coherence. When hues blend naturally, without abrupt boundaries or muddy transitions, they create a visual softness that resembles aged oil paint. Connoisseurs look for pieces where color does not overpower pattern, but supports it, producing a quiet, grounded elegance. Texture contributes equally to the stone's appeal. Fine-grained rhyolite takes a smooth, porcelain-like polish, allowing its internal artistry to emerge with clarity. Coarser material lacks this refinement, scattering light and diminishing detail. When a high-quality piece is polished correctly, the surface becomes a window into the mineral's history, a moment when lava cooled just slowly enough to express its movement in permanent form. Rhyolite also carries psychological value. Its beauty is not immediate, it must be revealed. This delayed appreciation resonates strongly with collectors who value subtlety over spectacle. The mineral asks for engagement, a closer look, a shift in angle, a reconsideration of what ordinary truly means. Those who understand rhyolite see not a field rock, but a natural painting shaped by pressure, heat, and time. In the world of connoisseurship, rhyolite stands as a reminder that art can emerge from the most modest places, and that nature, when given the right conditions, becomes an artist far more patient than any human. Ranked second, Aventurine. Looks boring until aventurescence appears. Aventurine is one of those minerals that rarely makes a strong first impression. In its raw form, it often looks muted, a soft green or brownish stone with a surface that seems quiet, unremarkable, almost too modest to belong in a display of finely selected minerals. Because of this understated appearance, aventurine is commonly grouped with low-value decorative stones, the type used for tumbled assortments or casual jewelry pieces. Yet this judgment misses the single optical phenomenon that elevates aventurine from ordinary to exceptional: aventurescence. Aventurescence is not a simple shimmer. It is a controlled scattering of light produced by microscopic inclusions, usually fuscite, hematite, or goethite, suspended within the crystal structure. These reflective particles align in subtle ways, turning the stone into a field where light moves deliberately rather than randomly. When the angle is right, the mineral transforms. A gentle tilt is enough to reveal a hidden layer of sparkling motion across the surface, a phenomenon that feels both surprising and refined. This transformation is what connoisseurs look for. The shift from plain to luminous is not just a visual effect, it is a test of quality. High-grade aventurine displays aventurescence that is even, dense, and directional. The sparkle should not appear as isolated flecks, but as a coordinated, shimmering glow that moves cohesively across the stone. Experts describe this as controlled brilliance, a sign that the mineral formed under conditions precise enough to align reflective inclusions without creating cloudiness or structural disruption. Color purity plays an equally important role. The most desirable aventurine exhibits a consistent body tone, usually a calm, balanced green, free from patches or muddy areas. The body color should serve as a soft backdrop, allowing the aventurescence to emerge naturally. When the hue is harmonious, the internal sparkle acquires a depth that feels almost atmospheric, as though the light were moving beneath a veil of color rather than merely reflecting off a surface. Transparency also influences value. While aventurine is typically opaque, high-quality specimens can display areas of subtle translucency, particularly along thin edges. This characteristic adds dimensionality, allowing the aventurescent particles to interact with light at different depths. It is a delicate interplay. Too much opacity dulls the effect, while too much translucency disrupts the mineral's cohesion. The best pieces achieve a balance that specialists instantly recognize. Surface finish is the final indicator of elite aventurine. When polished properly, top-grade material holds a soft, glassy sheen that highlights the internal shimmer without overwhelming it. Poorly cut stones scatter light chaotically, but a precise polish enhances the aventurescence, guiding the viewer's eye along the mineral's natural pathways. Aventurine, then, is a mineral of quiet transformation. It waits for the right moment, the right angle, the right light to reveal its character. For collectors who appreciate subtlety, this delayed reveal is not a flaw but a virtue. It is a reminder that true beauty often lives beneath the surface, and that a single flash of inner light can elevate even the most unassuming stone into something extraordinary. In first place, Chalcopyrite, the #1 common mineral with shockingly high collector value. Chalcopyrite has long carried a reputation that hides its true nature. To most people, it is simply fool's gold, a mineral mistaken for something more valuable and dismissed the moment its identity becomes clear. Its name is recognized yet rarely respected. Found in mine dumps, roadside stands, and beginner kits, Chalcopyrite appears to belong firmly in the category of common, inexpensive minerals. But this reputation dissolves quickly among collectors who understand the complexities of metallic minerals. To connoisseurs, Chalcopyrite holds a commanding position, not because it is rare, but because achieving elite-grade chalcopyrite requires a combination of geological precision and natural conditions so exact that only a tiny fraction of material ever reaches true collector quality. When it does, the transformation is striking. The defining trait of high-end chalcopyrite is its metallic purity. Ordinary examples appear dull, grainy, or tarnished. Exceptional specimens, however, display a golden metallic luster so deep and consistent that the mineral seems forged rather than formed. The surface behaves like polished metal, capturing highlights with sharpness and clarity. In these pieces, Chalcopyrite stands shoulder to shoulder with the finest metallic minerals, its brilliance instantly recognizable to experienced eyes. Then comes the phenomenon that elevates Chalcopyrite above expectations: natural iridescence. While treated specimens are common, genuine, naturally occurring, rainbow Chalcopyrite is exceedingly rare. In elite material, the surface blooms with purple, teal, cobalt blue, and rose gold tones, colors created not by artificial acids, but by delicate oxidation layers formed slowly over time. These colors must appear balanced, evenly distributed, and harmonious. Otherwise, the stone loses its elegance. When the iridescence is natural and disciplined, Chalcopyrite becomes one of the most visually captivating minerals in the common metal family. Structure adds another layer of connoisseurship. Perfect crystal clusters, sharp tetrahedral forms, well-defined edges, balanced growth, are extraordinarily hard to find. Chalcopyrite's softness makes pristine crystals difficult to extract without damage, which is why intact formations with full geometry can command significant admiration. When these crystals display mirror luster, crisp angles, and undisturbed surfaces, they achieve a sculptural presence rarely associated with a common mineral. Weight and density also signal quality. Elite chalcopyrite feels substantial, its mass reflecting high copper-iron purity and minimal internal fractures. This density contributes to a sense of gravitas, an unspoken reminder that the mineral belongs to an industrial lineage while simultaneously demanding aesthetic respect. What makes chalcopyrite truly remarkable is the gap between perception and reality. Few minerals demonstrate such a dramatic difference between ordinary material and top-tier specimens. This contrast is precisely why collectors prize it. Chalcopyrite challenges assumptions, rewarding only those who know how to distinguish surface gloss from structural excellence. In the world of connoisseurship, chalcopyrite stands as the ultimate revelation. A mineral once overlooked, now recognized as the crown jewel of common stones. Proof that extraordinary beauty often hides in the most familiar places. Common minerals rarely get the respect they deserve, yet each one on this list proves something simple. True value isn't always rare. It's often hidden in plain sight, waiting for the right eye to notice. If these stones change how minerals are seen, there is much more ahead. New stories, new structures, new surprises beneath the surface. Stay curious. Another journey starts soon.